Welcome to today's video. In this video, we're going to talk about differentiation. A part of differentiation is using the product rule. And the formula for product rule is given as y dx, which is equal to u dv dx plus v du dx. So I'm going to take an example under this. I'm given a function y is equal to 2x squared plus 6x, 2x cubed plus 5x squared. Now, how do we know there's a product rule, that the function requires a product rule? It involves multiplication. The product simply means it's multiplication. So that's what I mean. So this simply means we are multiplying this with this. So what we're going to do, we are going to say one of this is going to be u and the other will be v. So we say let u be equal to 2x squared plus 6x, and we say let v be equal to 2x cubed plus 5x squared. So we're going to differentiate u with respect to x and v with respect to x. So differentiating u with respect to x, we're going to have du dx will be equal to, when you differentiate this, 2 multiplied 2 is going to give us 4. Then we remove 1 from the power. 2 minus 1 is 1. So we're going to have 4x plus 6. Because when you this is just the power of 1, 1 minus 1 is 0. And anything raised to the power of 0 is 1. So when 1 multiplies 6, we're going to have 6. So then when we differentiate v with respect to x, we're going to have, this is going to give us 6x squared plus 10x. Now putting it into the equation, the formula, which is dy dx is equal to u dv dx plus v du dx. So we're going to have dy dx is equal to, our u is this, which is 2x squared plus 6x. Then our dv dx is our dv dx. So which is 6x squared plus 10x. Alright, so we're going to put our v plus v, this is v, which is 2x cubed plus 5x squared. Then du dx is 4x plus 6. So we're going to expand this bracket. So we're going to have dy dx will be equal to 2x squared multiplied 6x squared. We're going to have 12x4 plus this multiplying this, we're going to have 20x cubed plus this multiplying this, we're going to have 36x cubed. This multiplying this, we're going to have 60x squared. Come this other way. Plus this multiplying this, we're going to have 12x4. This multiplying this, we're going to have 12. Sorry, this is going to be 8. Sorry for that. This is 8. 2 times 4 is 8x4. Then 2 multiplying 6, we're going to have 12x cubed. This multiplying this, we're going to have 20x cubed. And this multiplying this, we're going to have 30x squared. Alright, getting that, so we're going to collect like terms. So by collecting like terms, we're going to have dy dx, which is equal to, now let's look at the equation. For x raised to the power of 4, we have this and we have this. So we're going to write 12x power 4 plus 8x power 4. So I've done with the highest power. Go to the next power, which is 3. So I'm going to have 20x cubed plus 36x cubed. Now let's see if there are others. Okay, we have this and this. So I'm going to put it down here. 12x cubed plus 20x cubed So we're going to go to the last part, which is 2. So we're going to have plus 60x squared plus 30x squared. So when we multiply it together, we're going to have the y, the x, which is equal to 12 plus 8, going to give us 20x4, plus 20 plus 36 plus 12 is going to give us 88x cubed, plus 60 plus 30x squared is going to give us 90x squared. So this is the answer when you use the product rule to differentiate for this function. We are going to take another example. Given a function y is equal to s cubed sine x. So we're going to say let x cubed be u and let v be sine x. So say let u be equal to s cubed and let v be equal to sine x. So differentiating u with respect to x and v with respect to x, we're going to have du dx, which is equal to 3s squared. Then our dv dx will be equal to, when you differentiate sine x, we are going to have cos x. So using the formula for product rule, which is dy dx is equal to u dv dx plus v du dx. Okay, so now we're going to have, I use x cubed, so we're going to put x cubed into our dv dx is given as cos x, plus our v is sine x, and our du dx is given as 3x squared. So we're going to have dy dx will equal to, when you expand this multiplying this, we're going to have x cubed cos x, plus when you multiply this, you're going to have 3x squared sine x. So this is the answer when you use product rule to differentiate this function. So we're going to take another example. Given a function y is equal to s cubed exponential x, so we say let our u be equal to x cubed, then our v be equal to exponential x. So we will differentiate with respect to x and differentiate with respect to x. So when we differentiate, we are going to have du dx will be given as 3x squared, then dv dx is given as exponential x. So the formula for product rule is given as dy dx, which is equal to u dv dx plus v du dx. So what's our u? Our u is given as x cubed, then our dv dx is given as exponential x, plus our v is exponential x, then du dx is given as 3x squared. So therefore dy dx is equal to s cubed exponential x plus 3x squared exponential x. So this is the answer when you differentiate this function using product rule. I really hope this video is very helpful to you.